high-end GPU that you'll find in a data center. And you have results for the MI250, which is a GPU by AMD. So we can run both on NVIDIA hardware and on AMD hardware, but we've optimized it for NVIDIA hardware so far. So there is maybe some more improvements coming to the AMD results. So this is just for one GPU. So we can also go to multiple GPUs. So if you have a system with 2 GPUs or 4 GPUs, the Compass Toolkit can actually use all of them. So here you can see that with the NVIDIA A100, for example, with 4 GPUs, you can get to almost 100 slices per minute. So if you think that a normal scan is maybe 200 slices, it would take like almost 2 minutes to do the reconstruction, which is a big improvement over what it was in the past, which is maybe around an hour, several hours. So we also made a demo, and I hope it plays. It doesn't play. Yeah. Okay. So we made a small demo showing this. Yeah. So on the left, you can see the results that we had basically at the start of the project. Then in the middle, you can see the Compass Toolkit running on the DAS6 cluster, which is the compute cluster that we use typically for this. And on the right, you can see the results for the Snellius supercomputer that is here on the Science Park, which has very, very good, very high-end GPUs. So this is the results of a brain scan from a volunteer. And yeah, you can basically see the results coming in slice per slice. So it's 172 slices. So you can see that the one from Snellius is already at 50% now. The one on the DAS is at 30%. And the one at the start of the project is at 4%. I think this takes 1 or 2 hours. So it's a brain scan. So I think it starts at the top of the head. So these are also the small slices. And then when it goes down, they get more and more complex, basically. So also the processing time depends on which slice it is processing. So I think the one on Snellius is almost done. And the one on DAS is also, it's like halfway now. But you can see that, the first one, it will take a while. So basically we went from, the time it takes, maybe 1 or 2 hours, and now it's basically to the time it takes you to get one coffee, basically. So to conclude, so we've built the Compass Toolkit. So it's a high performance library for this quantitative MRI research. We basically combine high performance with high ease of use. So we've shown that we can get the reconstruction time down from hours to several minutes. We show that we can use multiple GPUs and use them in parallel. But it's also very easy to use. So by using Julia, which is a scripting language, you can just call functions from the toolkit, and all the complexity of the GPU code is hidden from you. So the project is also part of the research software directory, where you can find more information. And of course, all the development is always open source under Apache 2. So if there's any questions, then...
Anything you could share?
Yeah, this is new.
That works.
Yeah.
All right. I'll come over here with my laptop so you can see me.
Oh, you use the audio from this one.
Yeah.
Okay.
All right. So for something completely different, because you talked about a project in life science, which is highly technical on the performance side. This project is in the social science section, and the project is called KANS, and that stands for Questionnaire and Nomination Software. Now, my background is not at all in anywhere near social science or questionnaire software. This is the button I should have. But when we got the project, the description was a bit like, okay, we need to create some survey software, like, for example, SurveyMonkey, you might know it, to do sociometric assessment. Well, what is sociometric assessment? That is that participant or members of a group can can answer questions about the other members of the group. So for example, you have a classroom with, in this case, Quick, Quack, and Quack, and Donald Duck. And Donald Duck is answering a question about Quick, Quack, and Quack. And the question is, who do you like most? And you can answer one or more people. And then you can combine all these answers of the different participants together and create a network analysis of the social network. And there was something about, okay, we need this for longitudinal studies, so to do this over multiple years, and we can track sort of the data of the participants over multiple years, and see how the social networks develop. Super interesting, doesn't sound like something terribly complicated. But then we started thinking about what are the requirements of this software. So it had to run these surveys and sort of do the management of these surveys remotely, right? So, or at least every user of the software had to interact with it on their own system. Before this, they had something which was written in C#, and that had to be installed on the laptop of every student in school, which was very impractical because they had to sort of spend a whole day or multiple days to do that. So this needs to be something web-based. People can just go to a website and fill in the survey, but also on the management side, uploading the personal information of the students that can join, and to actually build the survey. The sociometric assessment, that was one requirement. So we need to dynamically generate these answer options, and the answer options need to be the other members of the group, and they need to be identifiable. And also afterward, they need to be coupled to the responses from other participants, right? So the answer that someone gives needs to be connected, so you can make a graph. Of course, there's the privacy and security aspect. So the data needs to be securely stored, and we need to make sure that everyone interacting with the system cannot access data that they shouldn't have access to. So, for example, the researchers that do the research and set up the questions and set up the survey shouldn't be able to actually see the names of the people that answer the questions. And there's more like these. The longitudinal studies gave another problem, right? Because you need to store and connect the data. But if you completely anonymize the thing, you cannot connect multiple years because you don't know who is this person the next year. So we need to store some sort of longitudinal ID that can connect all the data points over the several years. And then there was another thing, which was the school reports. So actually, after having pseudonymized the participants, at some point they need to be de-pseudonymized again for the teachers to get an overview of who gets bullied, for example, in the class, because that was the original intent of the research, and the academic research came after that. This is the solution we come up with. I'm not going to go through it, but you see sort of three base blocks: the blue, the green, and the purple. And these sort of are the three sort of interconnected systems that we're developing, where the green part is based on existing open source survey software. And we're shoving IDs, different kinds of IDs, longitudinal IDs, short-lived IDs, report generation IDs, and the actual names of the student. We're shoving them through the system, making sure that the right data is at the right place and not in the wrong place at any moment. So the blue part is sort of the participant management system. And this is something that we built ourselves together with the Radboud University, the technical support group of the Radboud University, that put a lot of work in this. It's Python and Django based, so Django is a web framework for Python. And it's custom made, because this has some very specific requirements regarding how to store the groups of participants, how to deal with all these different IDs and to have a longitudinal database. And we wanted to run on the university server. Then there is the middle part, which is the actual survey software, where we have a survey server also running at Radboud, and the client, which is the interface that the participant is actually answering the questions, is running on the device of either the student or the mentor. And it shows the names of your fellow classmates. But it will only store the pseudonymized ID, so it's a random ID, so that the actual answers, the responses, don't have any personal information, at least no actual names in there. So we made 2 extensions to this Lime Survey, open source Lime Survey software. We made a couple of question themes that use data from groups of the participant, and we made an authentication plugin that actually also pulls in this data, the participant data from the group that you're a member of, from the participant management system. And then there's the last part, the purple part, because if you have the data, you need to analyze it and you need to do something with it. So there's the scientific analysis on one side, and there's the report generator, which generates the report for the schools and the mentors to actually analyze your students and see whether someone is in danger or might fall out of the social cohesion of the group. And these are to be written in R and R Markdown, because that's usually something that the researchers are familiar with in this field. So that it took us quite a long time to sort of analyze the requirements that they have and sort of figure out with the researchers what these requirements actually are, because they need help to formulate these requirements, and then come to this design. It needed some iterations as well, and then now we're actually building it. And yeah, so the blue and green part are more or less done, and we're now focusing on the purple data analysis and archiver. But I think the most important part of this project is collaboration. I think that's actually the most important part of any project, is that we have a clear communication and collaboration with the scientists on what they need, because they don't always know how to formulate what they need, or they don't know how to translate that in a technical solution. So that's why we need a really clear sort of together striving towards a goal. And the goal was clear at the start. We need to have this, it needs to be easy, it needs to be something that we can easily deploy at the schools, and that all the different users will not have a hard time using it. And I think that worked out pretty nicely because we had a very good collaboration. So yeah, I think that's my last slide. If there are any questions, I'm happy to answer.
Let me